In this segment, we'll take a look at what the software design looks like for our example project in image-guided neurosurgery. So again, just to re-illustrate the point, this is what the solution in fact looks like. We have a screen here. We have a set of cameras that look at the tools of the surgeon, and the position of the surgical pointer is shown on the screen. That is the basics of what the system does. It allows the surgeon to navigate during surgery. So to go back to a system requirement specification, we'll show an example of each of the kinds of requirements. Here's a functional requirement. The system shall be able to successfully import images from a PAC server. This is driven by these following users and use cases. And the comments, the ability to obtain images from the PAC is a critical component, as these images are needed for neuro navigation in the clinical workflow. If you don't have the images, you can't navigate with them, basically. And here's the non-functional requirement example. The system shall be able to notify the user if the current position of the surgical tool is out of date. We define this as more than a second old. This is a safety concern from risk analysis. And the comments, again, we're duplicating this slide. We must ensure that the neurosurgeon is not given false information at any point in the surgery as to the position of her tools, because this could lead to harm to the patient. So we start at the beginning, and we start with an incomplete list of workflows. It's incomplete because I'm not going to list all of them. You can find them in the textbook. One workflow could be to import structural MRI images, verify and store. We could import surgical plans, verify and store. We could import functional MRI data, threshold to appropriate level, and store the binary hotspots. Just to illustrate that, this is an example of a functional MRI. This is using pseudo colors, so purple is negative, yellow is positive. So the level here corresponds to the likelihood that a particular part of the brain corresponds to a certain task. And so if we threshold it and hide everything below a certain level, we may get those two small dots there, and those may be the regions we're interested in for a particular task. We need to perform image to Weld registration, and this is, we're going to take a look at it in some detail, to map the physical position of the patient to the images that we have from before surgery to allow navigation. And we may need to learn to display anatomical and functional images and tool locations in various views. So this is some of the workflows that we have to implement. So let's take a look at one of the workflows, the image to Weld registration. And here we'll break it up into 5 steps. First, we acquire matching Weld and image landmarks. This is one way to do it. So here's our patient, here's their image. We touch the nose in the physical world, we touch the nose with the mouse in the virtual world, and that gives us a pair of points. And we repeat this process for a number of points to acquire a number of corresponding landmarks. Then we compute a rigid mapping between the two using a least squares fit. So mathematically, this looks like this. If X are the points in the world, Y are the points in the image, we estimate this matrix A that we can multiply X by to get Y. So when we touch here, we get a position here. That's what A does. These 2 steps are actually all that our system needs to do theoretically to satisfy the user's needs. But you'll see the workflow has 3 more steps. Next, we compute a quality metric for fit. We prompt the user to navigate to specific locations to check the accuracy, touch the ear, touch the back of the head. And then we ask the user to confirm that the accuracy is good. If yes, we're done. Otherwise, we repeat. So what you have there is 2 functional steps and 3 risk management steps. And this illustrates the workflow, right? The first 2 are doing what the user needs, and the last 3 are verifying that we don't introduce risk or we do risk mitigation in the process. So if the mapping is wrong, we could get in trouble because the surgeon is now seeing on the screen the wrong location. So the way we get around it is first compute a quality metric for the fit. If it's bad, we tell the user this is a bad fit, try again. We prompt the user to check with a few more points, again, real world confirmation. And then we ask the user to confirm that the accuracy is good. And this is part of them owning the responsibility in some ways. Okay, I have checked, I followed your process. It's my fault now if there are problems. So this is risk management at multiple levels. The next step is to create the overall system design. For this particular thing, I came up with a 3 software package solution. You can see these packages A, B, and C. A is what the surgeon will use in the operating room. B is sort of a hidden database that will store data. And C is what the neurologists and the technologists will use outside the operating room to prepare for the solution. The blue boxes here are the different modules. The orange boxes here is the external world. So for example, let's see what happens in the operating room. We have tool tracking hardware. It connects to our tool tracking module, which provides information to the registration module, which also gets information from the database. This provides information on the mapping to the navigation module. And here come the images. And so now here we can draw the display. The others are similar in the same way. In addition to the design, we have to provide some sketches of the user interface, and this is for the two user-facing systems. Perhaps the navigation system will look like the BrainLab system, and this is inspired by an old version of Vivid Cranial. So this is this picture here. And perhaps the package that gets used outside the operating room will look like the software package on the bottom right. This is Yale Bioimage. It's an open source image viewer, image analysis package that we've developed over the last 10, 20 years. So this concludes our quick introduction to what this software design document will look like for our example project. And this concludes the big discussion of the software design document. In the next segment, we'll go outside of the main flow and we'll talk about usability engineering, and which is how we design software interfaces in particular to minimize user errors. What does that process look like? And that's another key risk management step in this process. Thank you.